Welcome, my dear learners, to today's episode on this very channel. Remember, we are still on indices and logarithms. We have a question on the board. Let's look at it. We have log of x to the base of 4 plus log of x to the base of 2, and this is equal to 6. We want to find the value for x which satisfies this logarithmic equation. But you agree with me that the bases of these two logarithmic expressions are not the same. We have a base of 4, we have a base of 2. So at this very point, we can't apply the multiplication law directly at this very point. But what we are going to do instead is to balance the bases. We want the bases to be the same. And how do we balance the bases? We can do that through the change of base approach. Now with the change of base approach, it says that when you have the logarithm of a number, let's say x, to the base of a number, let's say a, it can be written as a ratio of two logarithms. It can be written as what? A ratio of two logarithms. With each of these logarithms having the same base that is different from the base of the original logarithm. So it means we are going to pick any base that is different from a. So let's choose the base b. Now once you have this x, we move to the top, so we have x, and then the base of the original logarithm will also move to the down here, we have a. So at the end, we are going to have log of x to the base of b all over log of a to the base of b. And this is what we refer to as what? The change of base. So we are going to apply this change of base on log of x to the base of 4. So we are going to have log of x to the base of 4. We are going to write it as what? A ratio of two logarithms. And these two logarithms are going to have the same base that is different from the base of this logarithm, which is 4. Since we want to balance the bases, we want the bases to be the same as 2, we are going to pick the base 2. Now once we have this x will move to this side, so we have x, and then this 4 will move to this side. So we are going to get this is what we are going to get. So in place of log of x to the base of 4, we are going to substitute the whole of this. We have applied the change of base approach. So we have now at this very point, we have log of 4 to the base of 2. Now you agree with me that log of 4 to the base of 2 can be written as log of 2 raised to the power 2 to the base of 2. Because 2 times 2 raised to the power 2 will give us 4. It is the same as that. So in place of this, we are going to write log of 2 raised to the power 2 to the base of 2. Now at this same point, we can apply the power law. So this power will come in front to come and multiply the log. So you have 2 multiplying log of 2 to the base of 2. So in place of this log of 4 to the base of 2, we are going to write the whole of that. Now we have a property in logarithm which says that when you have the logarithm of a number, let's say, to the base of the same number, this gives us what? 1. If that's the case, when we have the logarithm of a number 2 to the base of 2, this will be equal to 1. So in place of log of 2 to the base of 2, we are going to have 1, and 2 times 1 will give us what? 2. So we are going to have log of s to the base of 2 all over what? 2 plus log of s to the base of 2, and this is equal to 6. Now looking at this, we have a fraction. Let's eliminate the fraction, and we can do that by multiplying through by the fraction that we want to eliminate. We are going to multiply through by the denominator 2. So we are going to have log of x to the base of 2 plus this times this will give us 2 log of x to the base of 2. That is 2 times 6 will give us 12. Now we have log of x to the base of 2, log of x to the base of 2. We can add them since they are the same. So we have 1 in front, so we are going to have 1 plus 2 give us 3. And then we pick one of the logarithms. We have log of x to the base of 2, and this is equal to 12. Now let's divide both sides of the equation by 3. So we have divide both sides by 3, both sides by 3. This 3 will cancel this 3. 3 into 12, we have 4. So at the end, we have log of x to the base of 2 is equal to 4. Now we want to find the value for x, so we can convert this into an exponential equation where the base of the logarithm will move and become the base of the index or the 4. So we are going to have s is equal to 2 raised to the power 4. And from here, you can see that our s is equal to 16, as easy as that. So the value for s, we satisfy this logarithmic equation, is s is equal to 16. This brings us to the end of today's lesson. See you tomorrow. Bye-bye.